Hi guys, good day and welcome to this online discussion. Today we'll still talk about peak EMF. Last time we derived an expression for the peak EMF of a rotating coil producing electrical energy as a result of changing magnetic field lines. So we shall be solving a problem today on how to employ this peak EMF formula. And the question we are going to solve now reads: a simple generator has 100 loop square coil 8 cm on one side. On the side, the question is, how fast must it turn in a 0.35 Tesla field to produce a 12 volts peak output? So the peak EMF here now is 12 volts. So we want to know the frequency. How fast must it turn in a 0.35 Tesla watts field? Of course, Tesla is a unit of magnetic field. So in a magnetic field, we want to know how fast it can turn if it has a peak output of what? 12 volts. If today is your first time of watching our videos, do well to subscribe and share our videos. Invite your friends and don't forget to comment on the areas you would want us to treat more. This is Neselefa Academy and we are discussing physics. Thank you. All right, welcome back. Let's begin solving the problem. The problem says a simple generator has 100 loop square coil 8.0 cm on a side. Full stop. How fast must it turn in a 0.35 Tesla field to produce a 12 volts peak output? Solution. In our last discussion, we found out that the peak EMF is given as N, A, B, then omega, where N is the number of turns of the coil, A is the area, B is the magnetic field, and omega is the what? Omega is the angular frequency. Alright, we are given that N is 100 turns, and one of the side, we say that we are told that is the generator has 100 loop square coil. So area is length times breadth. Of course, since it is a square, it will be L square. So we have 8 cm times 8 cm. So this will be 8 times 8 is 64 cm square. We are going to convert this to meter. How do we convert to meter? This is 64 times cm times what? Cm. So this is 64 times 10 to the power minus 4 meter square. So going further, we are given that B is 0.35 Tesla. So to find the frequency, how do we go about that? We know that omega angular frequency is given as 2 pi f. So in order to find f, we make it subject to the formula. We have omega upon 2 pi. So our interest in this formula now is to look for omega. Of course, what has given us hints to this is the peak EMF. The peak EMF is given, and it is given as 12 volts. So if we make omega subject of the formula, we have E subscript 0 upon N A B. Okay, and we are giving E subscript 0, which is the peak output, to be what? 12 volts. So we have 12. The number of turns is 100, and the area now is 64 times 10 to the power minus 4, and the magnetic field is 0.35 watt Tesla. If we resolve this, we have that the angular frequency will be 54 radian per second. You can press this in your calculator, and using this formula now, that F is omega upon 2 pi, we now have that the frequency will be 54 upon 2 pi, and we have 8.5 hertz. So this is the frequency. The question says, how fast must it turn in a 0.35 Tesla field? So the frequency, which is the number of cycles per second, is given as 8.5 hertz. So hertz is another unit of frequency. So if you have enjoyed this video, do well to subscribe to the channel, comment on the areas we want us to treat next, and don't forget to share this video, this amazing video, with or to your learning colleagues. In our next video, we shall solve other problems involving electromagnetism and physics in general. Do have a nice day ahead.